Hey, welcome back to Engineers Workshop. I wanted to introduce you to a new project that I'm going to be starting, and it's designed to increase I guess you'd call it the efficiency and broaden the range of tools that I can hold in the K&T. So the collet system that is in the spindle of this machine is a double taper collet that has a closure nut, but the actual taper inside the spindle matches what is now sold as the NMTB 30 taper, and this is one of the examples of that taper right there. And this is the threaded section for the draw rod, which does have a clearance pilot bore up through the spindle, but there is no through hole for the draw rod. So in order to hold these in, I have to come up with a system that uses something like the Collet Nut, and I'm going to be clamping on these flanges. Now, this is a Morse Taper 2 adapter. I also have an NMTB 30 to ER-40 collet chuck, and that requires a little bit different system. So let me show you what I developed, and we'll start machining these. The raw material for the Collet Nut is a commercial lock nut, and this is called a thin lock nut, but when you get to 2 1/4 inch, that's not very thin. So it's a 2 1/4 12, I believe. It's the only commercially available nut that I was able to find, and we don't need this feature, so we're going to be actually turning this down to a specific thickness, and we're going to have a registration shoulder on this for the retaining plate. The retaining plates are also made out of commercial washers, giant washers, that are about 3/8 of an inch thick. The OD is a little shy of what I need. I need a true 3.5 inch OD, so when these clean up, they're going to get a little bit small, but not a big deal. Going to have to get rid of the stamping edges off of this. And then, of course, with a nut, none of these faces are particularly true to the actual axis of the threads, so we're going to be putting this on the quill and facing this off, and then probably face the points of the hex off also, so I have a true concentric OD to register against. And then once this is flat, my logic is, since I've proven that I can mill things within a tenth or two, I can take a skim cut off the back once again take this on the mill, then I can flip it and I can hog this surface down to a rough thickness. Then I'll do all the finishing operations with the nut mounted on the quill itself. So like so many of my projects, I started modeling this in CAD, and the concept I wanted to go for was a nut that threaded onto the spindle, and then a retaining flange that would grab the shoulder of the NMTB 30 collet adapter. If you section this and you take a look at it, you can see that I added a shoulder to keep the retaining plate concentric to the nut. I didn't want to rely on the bolt heads to locate this. Now, even though for the Morse taper adapters, a through hole would work, for this ER-40 collet chuck adapter, which has features on both sides of the flange, I had to make a split flange and assemble it in place, and then this as an assembly would be screwed on to the nose of the K&T. The nice thing about that is, as you unscrew it, the taper on the flange will push the tapered NMTB tool holder out of the spindle, because that does tend to stick. I do have to tap those out when I have the conventional K&T collets in there. Now, normally this flange was not designed for clamping because there was a draw rod in the back end. I do not have a through hole through the spindle for the draw rod, so I do have to clamp from the outside. That does present some concentricity problems, which I'm still trying to deal with, but I think all in all, it gives me a lot of flexibility and the ability to, change out tools very quickly, especially diameter changes, going from small to large. This goes from, 1/8 inch all the way up to 1 1/8 inch. The next operation was to create a concentric feature to the true axis of rotation. Since this nut is fully threaded on the inside, you can't just indicate on that threaded area. So I wanted to tick the corners, the edges off of the 6 hex points. That way I could use those to indicate I need to put that shoulder to locate the retaining plate and put chamfers on the, outer edge of the body of the nut like most nuts have. And that means, create somewhat of a cylinder on the OD of the nut. So the first operation I feel was an outstanding success. I got a real nice finish, and I got the points dressed off, and this is a 3.875 nominal. I'm actually 1/1000ths over, which I'm not going to worry about. So I got a 3.876 OD, and I've got a perfectly flat surface here, or should I say perfectly perpendicular surface to the axis of rotation. So all I have to do now is dig out this nylock insert, and I can flip this over on the mill, dress this back side, and then use that as a machine surface to take the nut down to an almost finish dimension. So let's dig this out. That is tougher than you might imagine when you get up to that size. It never would have come out had I not turned off that lip. And I did raise up a tiny burr here in getting it out, so I'm going to stone the top surface of this flat. You saw from the video how hard this was. It was getting sparks off of it, so I think that's from the rolling operation. There'd be a lot of work hardening and getting that edge rolled over. I'm hoping that the rest of the body of the nut's not so hard. I've got my second nut in here, and I've run the tool in until it's just touching on the crests of those hex sides there, and I've got to come in another 50/1000ths on the radius for it to clean up to this point. And this is a 3.876 diameter, so I'm going to do it in 5/1000 increments at a time. Try a 10,000th depth of cut. Okay, next we've got the nut with the machine surface on 1, 2, 3 blocks. We're just looking for a nice cleanup of this surface. I've got it rough centered with the head offset, and I'm going to bring the quill down until it touches, and then probably a 5/1000ths or so cleanup. There we're touching. Let's see how consistent this back face is. Yeah, we have some run out. Bring it down for the low spot here. Okay, 5 for good measure. I'm going to reverse direction so I don't raise a burr on the inside. Marking the position of the flats on the vise so that I can load the next piece in. Didn't fully clean up on the back. We got to go another 5. After taking some light cuts on the back side of this nut to make it parallel to that front face, the best way to hog off all this material is just straight milling this across and flipping the nut for each pass. According to FS Wizard, this is a 30 Rockwell piece, essentially, you know, like a 4140 pre-heat treat. If I take a 1/4 inch depth of cut at 5 inches per minute, full height of this mill, that's going to use up basically all the horsepower this mill has. So let's see how this does. I'm going to monitor it very closely. Just walk straight across this. I got to remove a lot of material. It's going to be multiple passes. And I got the Y set with the back side of the cutter flush with this, so I can mill down to a specific thickness and just mill until I get to that target thickness. So let's fire up and see how we do. Set my incremental on the Y, dialing in 1/4 inch depth of cut. That's a lot of material removal. And of course we're not full height because we're milling off that front projection first. Cutting forces are pushing my Y-axis. Another 1/4 inch. This is going to be a full height cut once it gets rolling. I could feel the motor loading up. Well, I stalled the mill, I broke my end mill, and I moved my vise. Look at that. What I was trying to do was to come up with the quill to mill the top of that point, and ran out of travel, and so I ran out of where the mill was cutting. So I got to do some resetting of all this and go back to square one. Okay, after the wreck and after I got the motors working again, I switched over to my 7/8 diameter 5 flute roughing cutter, roughing mill, which is a high-speed steel titanium nitride. So this thing's gonna have to be run at by the numbers 175 RPM, which I can't go that low. So I'm down at 250, which is my minimum. And the feed's like 1 inch a minute, so a lot slower going for a 1/4 inch depth of cut. I'm trimming my vise. I'm at 0 here, and let's see how much I knock this thing out. It's a bunch. It's a bunch. I've got it back within a 1/2 thousandths. I had it within a couple of tenths before, but for facing this nut, it's going to be good enough. And the next operation, I'm going to be taking the vise off anyway, so let's just run with this. Okay, I'm going to come forward until I establish contact. I'm going to change my table speed back to 1 inch a minute. So my exact thickness on the DRO is 1.377. So the height of this cutter will let me do this in 2 passes now. That's a plus. I'm going to go slightly more than halfway with this first cut. I'm at 1.377. My finished thickness is 1.1875, 1 3/16. I want to leave, I don't know, 50, 60 thousandths for cleanup. So that means to take off about 129. Let's take off 125 thousandths in one pass. So we'll switch over to incremental. Dial in 125. This will be a taller cut. But I certainly have the cutter height to do it. Here's our reference surface and the roughed surface. Let's check for grins how parallel this is. I don't expect to get more than a thousandths or two, especially with this rough. Looks like we're within about a thousandths. No, 2 thousandths. That's good enough because I'm just going to go back on the spindle and I'll face both of these sides true and take it down to its finished thickness. So now we have to use that as our reference, make this parallel to it, and then take all of the thickness off of here. And so we're at 1 1/4, so we've got a 1/16 of an inch to remain to clean up. We came in contact with it. I gave it about 6 thousandths more to clean up, and just walk this across. I'm just looking to have a full cleanup all the way across. We're already not cleaning up all the way. Keep coming in 10 thousandths at a time so I can get that to fully clean up. This is way out of parallel. Once again, we're running off of it. $250 thousandths off of this side now. An unauthorized passenger on the table here. Be another 250. I wasn't crazy, my table feed was on. Another 125 thousandths has to come off. What I didn't do a very good job of explaining was I was running into a little bit of a wonky parallelism of the back face, because in order to do those initial facing cuts, doing the mill turning, I ran the nut up until it just stopped against the end of the thread on the spindle, and I thought that would keep it, perpendicular to the axis. It did not. It did allow it to cock. I went to Doozer for a solution to that, and he suggested that I just use good old Loctite 242 to freeze the nut onto the threads, and that way it'd be kind of neutral and balanced. And so in the upcoming segments of this video series, that was how I got better parallelism of those end faces of the nuts. But I was struggling with that in this first one. I'm going to break this into as many parts as necessary to get through the components of this. It was a pretty interesting build, and it did come out rather well. So I'll stop it for now and pick up right where we left off on the next segment. So until next time, thanks for watching everything here on Engineers Workshop, and as usual, stay safe.